Welcome class to the next video on fractional equations, and it's just like the name says. They're equations with fractions in it, and they're generally more complicated than some of the fractions you've seen in the past. I'm going to show you a first example here. Alright, if we take a look at this, every term in the equation is a fraction, and some of them have variables in it, so it's definitely not the same as having, a 1/2 x where we can just multiply by 2 to get rid of it. But it's essentially the same thing that you used to do. So we want to get rid of that 3, 5, and 15. That's what makes it a fraction. So to do that, you take all your denominators, your 3, your 5, your 15, and you figure out what number can all of those numbers go into. And you are figuring out the LCM, the least common multiple, or in this case, it's definitely the least common denominator. So the LCD would be 15. 3, 5, and 15 can all go into 15. So I'm going to take 15 and I'm going to multiply every single term by 15. When you multiply in an equation, you have to make sure you multiply every part, not just once on each side. And what happens is you have to do some reducing now. So if I take just this term right here, technically I have 15x over 3, but the 15 over 3 part can reduce. So off to the side you can be thinking 15 over 3, well that's 5. I show it like this. 3 goes into 15 5 times, so that there's 5 left there. It gets a little messy looking, but you can see what's left. There's a 5 and an x left. So this right here and this right here. So I get 5x. Right here I'm going to cross the 15 and the 5 out. And when you do 15 divided by 5, you get 3. Now there's a 3 and a 2x left, and you multiply that together to get 6x, and I just brought down the negative. And then over here, this is the easiest one of all. 15 over 15, they just cancel each other, they turn to 1. And 1 times negative 7 is still negative 7, so that's the only thing left. And now this becomes a really easy problem. You combine like terms. This is negative 1x equals negative 7. Divide by negative 1, and x equals positive 7. Alright, the check for this can get a little strange, so I'm going to show you the check. Let's see, we start with, let me erase this part. Start with the original. And then we're going to replace. Alright, now I just want to keep these a fraction. This is 14 now over 5. And I just want to see if I can make the left side be negative 7 over 15. So to do that, I'm going to make equivalent fractions. So instead of 7 over 3, I want it to be something over 15. And you do that by multiplying by 5. So I multiply the top by 5, and I get, is that 35? And then over here, to make this be 15, I'd multiply this by 3, so I have to multiply this by 3. Like 14 over 3, is that 42? And I just want to make sure that 35 minus 42 is actually negative 7. It is. Voila, that is how you do it. Alright, here's the next one. This one's a little bit more complicated because of the more than one term on top of a fraction. So x plus 3 is going to be where this is kind of new feeling. I'm going to start the same way though. I'm going to take all my denominators. I have 5 and I have 10. And the LCD of that is of course 10. 5 and 10 can both go into 10. So I want to go around and multiply everything by 10, including this one. So a lot of people forget that even if it didn't have a denominator, you still have to multiply it by 10. Because imagine if I only multiplied the left side by 10. That certainly wouldn't be equal anymore to the right side. Okay, so right here, I'm going to reduce this. 5 goes into 10 twice. But now I have 2 and an x plus 3. It is not 2x plus 3 because I want to multiply 2 by the whole thing, which means I have to distribute. So this is actually 2 in parentheses x plus 3. You could probably distribute as you wrote that next step, but I wanted to show you all the steps really carefully. 10 and 10 are gone, so there's only 3x left, equals, and then 10 times 7 is 70. So here is where I was talking about I have to distribute, so 2x plus 6. So I'm really multiplying the 2 times both things up here. Then minus 3x equals 70. This is another combined like terms, this one and this one. You get a negative 1x again, plus 6 equals 70. Minus 6. You get negative 1x equals negative, not negative, just 64. And then you get rid of the, the things just popped in. That was some of the, I paused and hit play again and it just popped up there. So x does equal negative 64. So I'm going to do the check. I'm going to use decimals this time so you can see the difference here. So I'm going to rewrite. And then we got to be careful with this negative. So negative 64 plus 3 over 5 minus 3 times negative 64 over 10. So this right here would be still be negative 61 over 5. And then minus, and then up top it's going to be negative 192 over 10. Forgot the 7 there. Alright, so this doesn't work out nicely. I'm going to grab my calculator. Negative 61 divided by 5 gives us negative 12.2. And then here we got to be careful. So it's going to be a minus, and then this thing's going to be a minus. So I'm just going to go ahead and change that to plus right now. Oh look, email. And then 192 over 10 is 19.2. I didn't need a calculator for that. And I think this works out nicely. We got the 2's will the point 2's will cancel. 19, positive 19 and negative 12 make 7. So it does work. You could have also thrown at any point after you plugged it in, like this one, you could throw that in the calculator just like that. And if you remember from the first day, it will say true if it is true, if it is going to work out. All right, and the very last one is one that you're going to do on your own. I'm not going to do this in the video, but I am going to be checking for it on your Cornell notes. So check for both an answer circled and that you did do the check. I don't care if you make equivalent fractions or equivalent decimals. And I apologize for any weirdness in this video. I had to go back and re-record things a couple different times, and if there was any kind of odd jumpiness, that was why. I hopefully get the kinks out in future screencasts. Okay, good luck. Send me a message on Schoology if you need any help.